Hello students, welcome to Crash Course AP Physics 1. This is Unit 2 going on, and in this is the third topic, frictional force. What is frictional force? Frictional force is the force generated by two surfaces that contact and slide against each other. Friction arises because the surface of the solid, if you see microscopically, they are not even. There is roughness on the surface. The surface is irregular, and that creates the friction. These forces mainly affected by the surface texture. If the surface texture is smooth, then the friction forces would be less. If it is rough or the surface is uneven, then the frictional forces would be higher. Let's first understand about static friction. So static friction is in the role when the body is at rest or when it is not moving or the body is stationary. So let's understand through this figure. There is a block, a rope is attached to it on which we are applying the force. When we are applying the less amount of force, this frictional force is also less. And when we increase the force, this frictional force would also increase. Still there is no movement, and when the movement just about to begin, and this is the condition where frictional force is maximum at this point. The static frictional force is maximum at this point. So maximum frictional force is equal to mu s into Fn. What is mu? It is the static frictional coefficient. And Fn is the normal force. Fn is the magnitude of the normal force. So for like when we start applying the force on the body, frictional force also rises, and there comes a point when the body is just about to begin its motion, and at that point this frictional force is maximum. Fs maximum is this point. Okay. Now let's understand kinetic frictional force. Kinetic friction is applicable when the object is in motion. So the magnitude of Fk, frictional force, is equal to mu k into Fn. So when the body is in motion, a continuous friction is applicable on the surface of this contact between object and the surface. So this force is known as kinetic friction. Mu is the coefficient of kinetic friction, and Fn is the normal force. Let's see numerical on friction force. A block of mass m initially moving on a rough surface as shown in this figure. Figure 2 shows four forces acting on the block. Which of the following best describe the motion of the block at the moment shown in this two figure? In figure 1, the body of mass m is moving in right direction. It has the velocity in right direction, and these are the forces acting on the body. Mg downward direction, normal upward direction, and this force, capital F force, which is applied on the body is on the right side, and this F, small f, this is the frictional force which is applied to the left side. As you can see from the arrows that this arrow length, this vector length is small as compared to this friction force vector. So what we understand, the net force, if this is the small f and this is the capital F, the net force would be in this direction, F minus F capital F. So this would be in left direction. So means there must be a net force acting in this direction. So the velocity is in right direction and the force in opposite direction, means the velocity must be decreasing with time. So although the block is moving to the right side, but the velocity is decreasing. So the correct option is C. The block is moving to the right but slowing down. Let's come to the next numerical. A system consists of three masses m1, m2 and m3 connected by the string over the pulley. The mass m1 hangs freely and m2 and m3 are on the rough horizontal table. The coefficient of friction is mu. Between them, the friction is mu, friction coefficient. The pulley is frictionless and of negligible mass. The downward oscillation. So this system is moving with a downward oscillation A. We have to tell that oscillation. So if this is moving with oscillation A, the whole system is moving with oscillation A. And we can assume these both blocks because the in this string the T is acting equal and opposite direction, which is the internal force. So we can consider them as a one body. It is given that the mass m1, m2 and m3 is equal to m. So all masses are equal. So this block would become the mass of 2m. Okay. Now let's draw the free body diagram for 2m. Free body diagram for this block of 2m. So 2mg must be acting downwards, and because it is the string is attached, this is string, there must be a tension, and the tension is string is same, so the tension would be same at this point, at the other point. So the tension in the left direction and the frictional force in the right direction. Normal force is acting upward. Okay. And the net oscillation is in this direction. So to write the equation for 2m block, I can write this equation like T minus Fr, which is a frictional force, is equal to 2m into A. So this is a equation where T minus Fr is your net force. F net is equal to the mass into oscillation. This is Newton's second law. So from this T minus Fr is equal to 2ma. And this Fr is what? Frictional force, and we know that the frictional force when the object is moving is equal to mu into like kinetic frictional force coefficient. So this frictional force would be equal to coefficient of friction, kinetic friction here, mu into normal. So normal is equal to 2mg. Let's just substitute it in this. T minus mu 2mg is equal to 2ma. So the value of tension is equal to 2ma plus mu into g. Right? This is our equation 1. Now let's come to this another block, m1 block, and draw the free body diagram for m1 block. So it is mass is m, mg must be acting downward, tension is acting upward, and there is a net oscillation which is in downward direction, so it would be a oscillation. So to write the equation, it would be mg minus t is equal to mass into oscillation. Net force is equal to mass into oscillation. In this equation, let's substitute the value of t. So it would be mg minus 2m a plus g into mu is equal to ma. Mg minus 2ma minus 2m mu g is equal to ma. So this ma plus 2ma, and this would be mg 1 minus 2 mu is equal to m 3ma. 3ma. M got cancelled. So the value of a is equal to g upon 3 1 minus 2 mu. C is the correct option. Let's come to next numerical. A plank with a box on it at one end is gradually raised from one end from the other end. As a result, at an angle of inclination of 30°, the box starts to slide and slides 4 meters down the plank in 4 seconds. The coefficient of static and kinetic friction between the box and the plank would be. So in this there is a block, and initially it was horizontal, It was completely horizontally and we lifted from the other end. So when it reaches to angle 30 degree, the block starts to slide. So means from point 1 to this point 2, only the static frictional force must have acted on the block, and once it reaches the point 2, it starts sliding, means the kinetic friction force come into play. Let's first find the static frictional force coefficient. Frictional force coefficient. So this is a slide and this is a block on which the block is. Mg is acting downwards, and if I just bifurcate the mg force in two components, it would be mg cos theta, because this angle is theta, it would be same as this theta, okay, or cos 30 degree, and this would be mg sin 30 degree, and the normal force is acting upward, and the frictional force must be acting in the opposite direction, relative direction. This frictional force would be equal to mg sin theta, then only this system is in equilibrium, means this block won't move. So the static frictional coefficient is applicable when the body is at rest or when it is not moving. So I can write that the frictional force is equal to mg sin 30 degree, or we know that maximum frictional force is at this point, the maximum frictional force is applicable. So maximum frictional force is equal to mu s into normal force is equal to mg sin theta. And from the diagram it is clear that normal force is equal to mg cos theta. Normal force is equal to mg cos theta. So I can replace it. Mu s is equal to mg sin 30 degree divided by mg cos 30 degree. So this would get cancelled and this value is tan 30 degree. So mu s is equal to 1 upon root 3. And when you solve this, it would be like 0.577 something, which is equivalent to 0.6. So the static frictional coefficient is equal to 0.6. Now let's solve for kinetic frictional coefficient. Or kinetic friction would be active only when there is a movement in the object. So a net acceleration would be there, and this acceleration we can find with the help of the value given is in this question: slides 4 meter down the plank in 4 seconds. So distance traveled is equal to 4 meter and the time is given, which is 4 seconds. So we know from the second equation of constant acceleration kinetic equation that S is equal to ut plus half at square. So initial velocity is 0, that's why it is 0, and the distance is 4 meter is equal to half acceleration into time 4 square. So the acceleration would be 1 upon 2 meter per second square. I am writing the equation this side for from this point. I am solving it here at this point. So when the acceleration is there, which is equal to half meter per second square, we can write the equation for when the acceleration is there. For that I am writing the equation mg sin theta minus the frictional force is equal to ma, and the frictional force in this case is equal to minus mu k, which is the coefficient of kinetic friction, into normal force, and we know normal force is mg cos theta. So in this equation mg sin theta minus mu k mg cos theta is equal to mass into acceleration. So mass got cancelled, and instead of theta we can write 30 degree, and the value for this would be g sin 30 minus half, which is the acceleration, divided by cos 30 degree into g, and this would be equal to coefficient of kinetic friction. After substituting all the values, g as 9.8 sin 30 minus half divided by g into cos 30, mu k would be equal to 0.5. Okay. So A is your correct option, mu s and mu k. That's all from my side. Like the video, comment it, and you can subscribe the channel for the next update. See you in the next video.